Priya, and I'm going to present my project on data 608. I have done it on NYC 311 complaint analysis, and I have given my write-up on visualization here. That is where the data source comes from, the parameters of the data set, explained about a little about the NYC 311 open data set, and where the data set comes from and what it shows and why is it important. So the 311 NYC dataset is given by the government of New York City, and it provides customer service in all kinds of complaints that we file in. It can be about the noise that is residential, streets or sidewalk, and if it's overspeeding or any complaint regarding the construction works going on. So my main aim about the project was to analyze and build visualizations of these issues around the New York City, that is all the boroughs, and doing text mining analysis of these service requests, exploring the historical dataset of NYC 311, and also using the Swizzit package to do the Twitter comment analysis. And this was the main challenging part of the project. So as we move on to the data preparation, we import the libraries, and I have used Socrata API here to load my data. And moving ahead, for exploration and visualization, I have just a second. Yeah. So I have firstly I have visualized the topmost most common complaint types. So as we can predict from the graph that the most common complaint type is the residential noise category, and after that follows is the non-emergency police matter, and after that is the street or sidewalk. After that, I have analyzed the most common complaint types by borough and status, like which borough has the most number of complaints. Here we can see is in this graph, what we can see is the status of all the complaints and all the category types in which the status is. So as we can see, the highest number, that is 150 number of complaints, is as we can see here, it's Brooklyn, and as we can see here, it's again the noise and residential data set, and it is in the closed category, so which is a good thing. That tells about NYC 311 to us. And I also want to tell at this point that this is a dynamic data set, that it is update every 24 hours. So the output that I'm saying right now might not be the same that anyone will run it after a week or after 2 or 3 months. So it will keep on changing. After that, I have done service request resolutions, tidying and analysis using the tidy text package. In that, first what I wanted to see was the most frequent words used in NYC 311 SRs. In that, I have used the stop words data so that I can see which all words are the most common used by borough. So here I have plotted it so that it can be more clear. Here, as we can see, the most top words used in the NYC 311 SRs by borough. So in most of the cases, it's the complaint followed by police, then words department, and so on and so forth. After that, I have used to make it more approximate and appropriately meaningful, I have used the TF-IDF concept. What it is, it stands for term frequency, inverse document frequency. What it tells us, it reveals us the most important words in a corpus of words or a document of words, and it gives each word a percentage, that is how much that word is important or how much that word was used in the document. So I have analyzed it by borough. As we can see the graph, it will be more clear to us. So for Brooklyn, the most distinctive words according to TF-IDF analysis used was word complaint, and in Brooklyn it was contact. In here Manhattan, as we can see, it was contact with other few words like verify, inspection, and all. And we can also see the lowest most distinctive words used by borough, that is in Manhattan, is environmental and state and it's action. in Queens its address, and so on. Now we move on to the map analysis that I did. In this, what we can find is I have taken the longitude and latitude into consideration to do this map analysis. Now we can see, as I'm going to show the graph ahead, we can see all the complaint type category here by borough and all the frequency, that is if there are what I have set it here is greater than 2, so all the complaint types which is greater than 2 category, it will be shown on the map plotting so that we can avoid any unimportant analysis. So in map plotting here, as we can see the number of service requests, we will go by the greatest. Here it's the noise or street sidewalk, so that's where most of the complaint types is based on the latitude and longitude. After that, we are going to use the package TM for doing the SR resolution styling and analysis. Now in the TM vignette, it's meant for the text mining in R, utilizing the text mining framework provided by the package TM. After loading the library, we are gonna see some non-standard characters, like we will clean up those characters and we will create a corpus of those words, which we are going to call SR corpus. Here what we can see that in those terms there was some sparsity, that is sparsity means the terms which are 0 and it's not important, it doesn't add to anything to our data, so we are going to remove that sparsity. And here, as we can see, from 93% it has been reduced to 46%. After that, we will analyze the top terms by frequency, which was mentioned at least 50 times, so it was 10 times the length of those frequency. And here we will display the top terms, so that is action, available, condition, complaint, department, and so on. Now what I have done is I wanted to see the association between the word action with all these other words, the word available with all the other words, so just to see some interesting insights. So here I have used the function find association and also the function lapply to get that result. Here we can see that the term action is associated with the term fix by 88%, and the term available is associated with word information by 84%, and the term department is associated with term police by 84%, and so on. Now I have created a word cloud for the top terms used in SRs to give a different kind of visualization here. And after that, we move to the most challenging part of the project, that was NYC 311 tweet analysis. This was challenging for me because I don't know how the process was earlier, but currently it's kind of strict and with a lot of restrictions. So first what we have to do, we have to develop a developer account, create a developer account in Twitter, and then we have to give all the information, like what app am I creating, what information will I be using, which users and which am I going to use any of their personal information or anything. Everything I had to describe in like about 200 to 250 words minimum. So yeah, so and this process took at least 3 days for me to get the permission from Twitter, so that was most challenging. After that, here these are the fake keys in just to explain about the project. So you can replace these keys with your own keys and the project will run successfully. After that, I have tried to search and collect all the a particular number of tweets doing any mention to NYC 311 term, that is a hashtag user or follower, etc. So we have all the resultant here. These are the sample users tweeting about NYC 311, and again it's a daily data, it's updated every 24 hours, so this data will not be the same tomorrow if you run this project. So that's what's interesting. Now we can see the time series plot of NYC311. This is for past 7 to 9 days how many number of tweets have been there. And here, as we can see, after May 8th there was a gradual decrease from May 9th to around May 10th. I believe it was because of COVID-19 conditions that the tweets decreased on NYC 311, sorry. And then yeah, this was something unique I did. So using the Swizzit package, I do the sentiment analysis. What this package does, it breaks all the words of the tweets into 10 different emotions. That is following anger, anticipation, fear, sadness, negative, positive, etc. And the first thing I did was I have rated all the tweets based on the emotion that they display. So whichever emotion that a particular tweet will display, it will mark against it as 1. If it's multiple, then it will mark multiple ones against it. And after that we move on to sentiment scoring. Now what this means is to put the number of positive reviews in relation to the number of negative reviews. So I will get a value, that is send.value, of all the tweets I have. Now I can segregate based on that. That is, I can take the most positive tweet, most negative tweet, and the neutral tweet, and based on that I'm going to do analysis. So now here I'm going to see the positive tweets, which are these. This is the most positive tweet, in which I have given passed the parameter send.value to the function max. Now we have the negative tweets. Similarly, this is the most negative tweet, and then the neutral tweets. After that, we move on to the final result of our project, which is the total tweets by sentiments using the Plotly package. Here we can see the positive tweet is 522, neutral is 115, negative is 237 in number. So leveraging the platform of Twitter, the getting so many positive tweets is a good side factor of NYC311. So we can sum up the result that NYC311 is capable of tackling all those complaints in time and then updating their data daily. So yeah, that's it. And I have drafted all the issues that I faced and the conclusions. Please do go through my RMD file. Thank you so much.